Good morning. This is second video which we are preparing for preparation of Insem and NPTEL examination. So now here if you will see we have to analyze it to determine value of RA, value of RB and value of RC. Now unknown we have 3 RA, RB and RC and we have to go for 3 equilibrium equation. So we have summation Fy0, Fx will not be there, no horizontal reaction or force. Then as we have this at E, we have internal hinge. We have this distance 2 meter, we have this distance 2 meters. This is given. And then we have two equations, moment about E, that is internal hinge is 0 from left part. And then we have moment about E0 from a right part. Means we have to consider only left part of E and we have to consider only right part of E. So now we will go first, we will consider only right part. So moment about E equal to 0, we are considering only right part. Do not separate out the beam, will be confusing part. So we have to consider only this portion. Now what will be here? So we have UDL of 2 meter. So we will get total UDL 30 into 2, which will be 60 kilonewton. And then we have this will be 1 meter. It will act at center 1 meter. Now we will have minus RC into 2 due to reaction plus 60 into 1 equal to 0 and we will get therefore RC that is equal to 30 kilonewtons. Now second we will consider only this part and we will take a moment about E0. Now again we have this will be 2 meters on left side, so 30 into 2 we have 60 kilonewton. And then again it will act at center 1 meter and 1 meter. Then we have moment about E from left part. And then we will have this RA into 6 minus AT into 4. So you can see we have this will be RA into this 6 minus we have 80 into this 2. And now due to UDL, we have again 60 into 1. So minus 60 into 1 equal to, sorry, we have RB again. So plus RB into 2 and that is equal to 0. And from this we will get 6RA plus 2RB equal to 380 kilonewton. 380. This is 80 into 4 we have 320 and plus 60 380. Now divide whole equation by 2 we will get 3RA plus RB and that is equal to 190. We know value of RC we have 30 kilonewton. So now we will this will be equation 1. Now we will take summation Fy0 and we will have this as RA plus RB plus RC minus we are taking all loads 80 minus 30 into 4 equal to 0 and we will get RA plus RB which is equal to 120 plus 80 minus 30 will be equal to 170. This is second. And we will solve these two equations. So we have 3RA plus RB that is equal to 190, equation 1, and then RA plus RB equal to 170. And when we will solve this, we have this as 2RA and that is equal to 20 and RA we have equal to 10 kilonewtons. Then by using equation 2, we have RA plus RB equal to 170 and from this we will get RB equal to 160. Now we can verify this. We will take now RA we know. Sorry, we will take moment about RA 0 and we will verify RB. So verify RB. Then we will have moment about A0. And then we will take moment of all. So we are due to 80 first clockwise 80 into 2, then due to RB anti-clockwise minus RB into 4, then due to UDL. Now we have to consider whole UDL because this is on one side. When we will take moment about E0, half UDL on right side, half UDL on left side. So we have to consider accordingly. So minus RB into 4 plus now UDL we have 30 into 4. It will act at center, that is at E, and therefore we have distance from A to E 2 meter to 4 meter, and this 2 meter 6 meter. So 30 into 4 into 6, then we have minus due to RC. We have value of RC 30 kilonewton. So 30 into 8, and that is equal to 0. And from this we will get value of RB. If we will calculate 4RB, then we will have 30 into 4, 120 into 6. So we have this value 720. Then 30 into 8 plus 240. And then 80 into 2, 160. Sorry, 80 into 2, this 240 we have minus, and 80 into 2 we have plus 160. And from this we will get 4RB, that is equal to 640, and RB we will get 160. So you can see from both way we will get same answer of RB. So likewise you have to solve the problem. Then we will have this problem. Now whatever complications you think is not there, now you can solve this problem also very easily. We have to first go for total load. Now triangular load on opposite sides we have, so we need not require to make it half. So I will make total load of this. So now you can see we have total load of this. For this triangle we have this value, that is half 16 into 3. So half 16 into 3, if you will calculate, then you will get this value, that is equal to 24 kilonewtons, because 2 8s are 6, 8 3s are 24. Where it will act? So it will act at 1 meter, because from right angle 1/3 we have, so 1 meter from here. Now if we will go for this, then we have half 30 into 6. So we will get 215, and 15 6 are 90. Where it will act? Again from right angle we have 1/3, from D we have 2/3. So that is 1 meter left and 2 meter in case of right UVL. Now we have to find the values. First we will find RE. So we have to take first that part where we have one unknown only. On this left side we have two unknowns. We have RA also one unknown, and then we have MA also another unknown. So we will not take left part, we will take right part. We have only RE as unknown. We will take moment about C0. Then what we will get due to this 90. Now this is 2 meter, this is 4 meter. So 4 meter plus 2 meter. So your total load will act at 6 meter from this. And then we have 9 RE minus RE into. So we have total distance 6 plus 2, 8. Then we have plus 90 into. We have seen we have 6, and that is equal to 0. And from this we will get RE, that is equal to. So we have 90 into 6 divided by 8, and we have 67.5 kilonewtons. Then we will have another equation Fy0. Then we have RA. Then we have minus 24. Then we have minus 45, and then minus 90, and that is equal to 0. sorry, RA minus 24 minus 45 minus 90, and then we have plus RE, and that is equal to 0. And then from this we will get RA is equal to, so we have value of RE, we have 67.5, and by substituting all these values we have 90 plus 45 plus 24 minus 67.5, and we have this value that is equal to 91.5 kilonewtons. Now we know value of RA, we know value of RE. Now we will take moment about C. So this is about C, we have taken right part. Now we will take moment about C and we will take left part. So moment about C equal to 0, we are considering left part. Now we will get it as minus MA, then plus. Now I know value of RA, so I will directly take RA, need not require to involve one unknown again. So plus 91.5 into 6, distance between A to C. And then we have due to UVL, so minus 24. Now it will act 2 meter from B, and then this has 3 meters. So total we will get this distance that is equal to 5 meters. So minus 24 into 5, and that is equal to 0. And we will get value of MA that is equal to 91.5 into 6 minus 120, and we will get 429 kilonewton meter. Now you can verify it. So how we will verify it? We will take moment about A0, and then RE we will put it as 67.5. Then we will have due to RE, so minus 67.5 into 6 plus 2 8, 3 11 plus 3 14. So we have into 14. Then due to UVL first 90 into, so we have this as 4 meter, 2 6 3 9 and 3 12, or 14 minus 2, so we have 12. Then due to 45 plus 45 into 6, and then plus 24 into 1 equal to 0. Sorry, minus MA equal to 0. And from this we will get value of MA that is equal to, we will have this value 67.5 into 14 plus 90 into 12 plus 45 into 6 plus 24. So same value we got from here also, 429 kilonewton meter. So you can take from any way, you will get values correctly. Then we have this as last example in this. So now we have again RA we have over here as summation fx equal to 0. So my value of HC becomes 0. So first equation, fx equal to 0, and therefore HC equal to 0, no horizontal load. So now we have 3 unknowns only. So then here we have RC, and then we have here that is MC. So we will take MC. Now again on bottom side of B we have 2 unknowns, and on left side of B we have 1 unknown only. So we will have unknown, one RA, another RC, third MC, and fourth HC. 4 equations, Fx 0 because HC is there, Fy 0, and then again as we have hinge, moment about B0 from left part and moment about B0 from bottom part. Now we will take first from left part. So moment about B equal to 0 and left part. And then what we will get? We will get RA into 3. Now total load will act at center. So we have that will be 6 into 3 into 1.5. Sorry, 6 into 3. So we have 18 and it will act at 1.5 meters. So we have 1.5. So RA into 3 into minus 18 into 1.5 and that is equal to 0. And we will get RA that is equal to 9 kilonewtons. Now RA 9 kilonewton, we will apply summation Fy is equal to 0. We have RA minus 18 plus RC equal to 0 and therefore we will get RC that is equal to 9 kilonewton. Now we will consider moment about B equal to 0, that is bottom part. And then we have due to RC passes through B0, HC 0 and therefore we have MC that is equal to 0. Now we can check it moment about C we will take and check it is coming 0 or not. So we have RA now we have that is 9 kilonewton. So I will take moment about C0 of whole part. Whole part we are considering. So we have 9 into 3 because distance between A and C 3 meter. Then we have minus due to 18 we have 18 into 1.5. So minus 18 into 1.5 plus m suffix c equal to 0 and therefore we will get m suffix c that is 0. So you can find from any side you will get value same. So no change will be there. So this you can have verify of MC. So likewise, we have to solve the problems related with internal hinge. So today we will stop here only. So thank you.